Alright guys, I'm out coaching today, so we have a little bit new stuff to get through that couldn't wait until I get back. It's not a whole lot different than what we've been doing, it's just kind of a little twist. I don't think you'll have a big problem with it, so let's just get started. If we want to graph y equals x squared plus 5x plus 15, well, we got to factor it first, right? Scoot this over so you guys can see a little bit better. We're going to start with x and x. This is positive. So we're going to do two of these, so two positives. Factors of 15 that add up to 5. Factors of 15 are 1 times 15, 2 doesn't work, or 3 times 5. I don't see factors of 15 that add up to 5, though, is the problem. Okay, so the problem is, if I can't find factors that add up to 5, I can't find the zeros. So that's the problem. There are no zeros. Okay? We have something like this. This is what the graph looks like. There are no roots. So how are we going to graph parabolas that don't have zeros? Well, we're going to use something we've been doing to find a new way around this problem. Every parabola we've graphed so far has crossed the x-axis somewhere, and we've had two roots. Roots, zeros, x-intercepts, whatever you want to call them. This one, and many others like it, will never touch, so there are no zeros. Okay, so let's look at how we used to do this. Find the vertex of the function y equals negative 2x squared plus 5x by first finding the x value halfway between the x-intercepts. So I need to find my x-intercepts. Okay, so we're going to factor out what we can here. I can take out a negative 2. So leave me with x squared plus, what would be minus, positive divided by negative, 5 halves x. And I can also take an x out, so I should have taken out a negative 2x to begin with. Leaves me with an x minus 5 halves. So I have two options here. This could be equal to 0, negative 2x equals 0, or this could be equal to 0. X minus 5 halves equals 0. Because if I want to find the zeros, or the x-intercepts, I have to set it equal to 0. Okay? Solve them both. We'll divide by negative 2. X equals 0 divided by anything is still 0. Or add 5 halves to both sides. X equals 5 halves. Those are my x-intercepts. We need to find the x value that's halfway between them. So 0 plus 5 halves divided by 2 is going to be 5 halves divided by 2. I'm just going to punch that in on a calculator. There's no reason to stress about it. 5 divided by 2 is going to be 2.5. We're going to divide that by 2. 1.25. Okay, so that's of my vertex. That is the x-coordinate. So then I'm going to take that value, and I'm going to store it using this button. Whoops, you can't see it. Using this button right down here, I'm going to store it for x. Now I'm going to type in my original function, y equals negative 2x squared minus plus 5x. So negative 2x squared plus 5x. My calculator looks a little bit different than yours, but the buttons are all in the same place. We're going to go ahead and hit enter. 3.125. So that's the y-coordinate of my vertex, 3.125. So that's how we've been doing it. It works just fine. We could check this by graphing it on Desmos, but since I'm using paper, that's not going to work. Okay, so you do it now. Same thing. Take out the common factor, solve for the x-intercepts, and find the vertex. Go ahead and pause the video for a few minutes and give it your best shot. There's no c, right? We're used to there being a term out here, but it doesn't matter. We can still do it. So go ahead and take a couple minutes, pause the video, and see if you guys can figure it out. Then I'll come back and do it with you. Okay, let's give it a shot. I need to take out a 5, and there's x's in both of these, so I can take out an x also. That leaves me with x minus 12/5. Okay, set it equal to 0 because I want to find the x-intercepts. So that could be equal to 0. Or this could be equal to 0. Divide by 5. 0 divided by anything is still 0. Add 12/5. Add 12/5. X equals 12/5. Those are my two y-intercepts, or my zeros. 0, 0, and 12/5 and 0. Those are my x-intercepts. The points are across the x-axis. To find the vertex, the x-coordinate is halfway between these two. So let's add them up. And we just do it all on the calculator this time. No reason to mess around with this. So 12/5 is 2.4. Plus 0. You can do that if you want to. It's not going to change, I promise. Divide it by 2. We're still taking the average. 1.2. So that's the x-coordinate of the vertex, 1.2. We're going to store that using the store button. Up here to x. Enter. And type in the original equation, which was 5x squared minus 12x negative 7.2. There's the vertex. Okay, and again, we could graph it. Plot our 3 points, plot this guy, and off we go. But these don't fit that pattern we started with. These two equations we just factored both cross the x-axis. We know that that happens because I found x-intercepts. If I jump back to this first one that we started with, this guy, there were no roots. It doesn't cross. So we're not really figuring out how to do this yet. Or are we? Okay, so let's try it with no numbers. Let's try it with letters. Okay, so what can I take out of both of these? Well, we've been taking out this guy because that needs to be a 1. So we're going to divide by a. There's x's in both, so I'm going to take out an x. That leaves me with x, because a divided by a will disappear. X squared divided by x becomes x. Plus, divide this by a. I have b over a, and that's it. So if I was following the process, I'd set it equal to 0. Remember, b and a are just numbers, so that could be equal to 0, or that could be equal to 0. So either divide by a is just a number, so 0 divided by a number is still 0, or subtract ba. Negative b over a equals x. So those are my two zeros. I want to find the vertex. Okay, we have to find the x value that's halfway between the x-intercepts. So I'm going to add 0 plus negative b over a and divide that by 2. Well, 0 plus anything doesn't matter, right? So that's just negative b over a divided by 2. So if I'm going to divide something by something else, this could just be in the denominator. And here I'll show you why again. That's 2 over 1. When I divide by a fraction, we multiply by its reciprocal. So I have negative b over a times 1 over 2. This and this are exactly the same. Divide by a fraction, so multiply by its reciprocal instead. Multiply straight across. Negative b over a times 2 is 2a. Now that is the x-coordinate of my vertex. And what's really cool about what we just did is we figured out how to find the x-coordinate of the vertex in one step without numbers. So instead of doing all of this to get here, we can just take whatever the middle number is, the opposite of that one. So if it's positive, we'll use a negative. If this number is negative, we'd make it positive. And divide it by 2 times whatever a is, and that gives you the x-coordinate. So the x-coordinate of the vertex will always be located at negative b divided by 2 times a. And remember, a and b are just these guys right here, whatever these two numbers are. Even if there is a c, it doesn't make any difference because there was no c and it didn't end up in any of my stuff over here. So only the first two terms matter. Negative b, so opposite of this, divided by 2 times that number, will always give you the vertex, or the x-coordinate of the vertex. So let's try it. Okay. Quick set of notes real quick just to get down. I'll leave this here and talk for a minute. Go ahead and copy this down. If you run out of time, you can pause the video. So, we're looking at this general form right here. ax squared plus bx plus c, all three terms. If a is greater than 0, so if this number is bigger than 1, if it's positive, not bigger than 1, if it's bigger than 0, meaning if it's positive, it opens up. We knew that. If it's a negative number, then it opens down. We knew that too. This is new right here. The axis of symmetry is at this guy, which is exactly the same as the vertex, right? This is where the vertex is, so it's also where the axis of symmetry is. The axis of symmetry is this line that goes right through the vertex. It's a vertical line, and it cuts the parabola in half. It goes right through the vertex. So the x-coordinate of the vertex is the equation of that line as well. Okay. Number 4 says use the x value of the axis of symmetry, so this, the x-coordinate of the vertex also, to find the y value of the vertex. So once we find that x value, we still just plug it right back in for x up here using the store function on our calculator. So the y-intercept is still going to be 0 and then whatever this number is. Because when I plug in 0 for x, that's still 0, that's still 0, that's all that's left. Okay, so go ahead and make sure you have this down. If you want to draw the picture, that's fine too. Go ahead and pause it. Take the time you need. I'm going to go ahead and move forward. Alright, so let's do all of that all at once. Find the axis of symmetry, the vertex, and the y-intercept of the graph. So here's the equation. The axis of symmetry is going to be equal to x equals negative b over 2a. We know that. So let's see. Here's b. So x equals negative b divided by 2 times a. Well, a is right here. If you don't see it, it means it must be a 1. So 2 times 1. So x equals negative 2 divided by 2, which means that x equals negative 1. That is the axis of symmetry. So if I wanted to come over here, that's a line. That's a vertical line right here. At negative 1. Okay? So, that one's done. The x-coordinate of the vertex. Well, guess what? That's the exact same thing. Here's my vertex. The x-coordinate is negative b over 2a. So the x-coordinate of the vertex is also negative 1. So here's my vertex. Let's just put it down here where there's room. The x-coordinate has to be the same as the axis of symmetry. So it's a negative 1. Negative b over 2a. You don't need to do it again. You can to check yourself, but it's going to be the same. To find the y-coordinate, we're just going to plug it back in. Okay, so let me set this up so you can see all the buttons here. Negative 1. We're going to store that for x. Store button's down here. X button's up here. We've been doing this a while now. Okay, storing negative 1, that's the x value of the vertex. Now let's plug it into the original equation. X squared plus 2x plus 5. And it's 4. So the y-coordinate of the vertex is 4. So let's plot that point. Negative 1, and it's up here at 4. The y-intercept is always going to be 0, c, meaning this guy. Because when I plug in a 0 up here, 0 squared is 0, a times 0 is 0, so that whole term becomes 0. When I times anything, multiply anything by 0, this becomes 0 also. Right? 0. So all that's left is my c. So, in this case, That's 5. So I can plot that point. Now the downside to this is that you only have 2 points. So it's really hard to draw our parabola to sketch that graph. So what you have to know, if you remember the last couple days we've been crossing out that point of reflection. We haven't been worried about that yet. It's just this same point, but on the other side. So it's 1 away from the vertex. So over here, it's 1 away from the vertex at the same height. Okay, and then just sketch it the best you can. Running out of ink here. Okay, and you're set. So it's a little bit less work than all that factoring, isn't it? I'll have all these pages stapled together in the sub notes, so if you guys want to look at any of these after the video's done, you can grab them and take a peek. Okay, we're almost done. So one more time. Axis of symmetry is going to be equal to x equals negative b over 2a. That's a big thing to know. Negative b over 2a. Make sure that is in your notes. So let's do it. X equals negative b. So this is b. So negative b would be negative 4 divided by 2 times a. Well, here's a. Okay, so that's negative 4 divided by 4. Hey, it's the same thing. Just a coincidence. It won't always be the same thing. So the axis of symmetry is x equals negative 1. So we can sketch that line again. It's always a vertical line. It's going to cut the parabola in half, and that tells me where my vertex will be. The x-coordinate of the vertex is also negative b over 2a. So we'll put it down here where there's lots of room. Still negative 1. So same thing. We're going to store negative 1 for x. I don't really have to do it again. My calculator still remembers, but we'll reset it anyway. 2x squared plus 4x plus 3. It's going to be a positive 1. So if I go to plot that, negative 1, 1, it's right here. Okay, it's going to open upwards because this is positive, so we know it's going to go this way. It won't cross the x-axis, or we wouldn't have this problem. The y-intercept, remember, is 0 and then c. So c in this case is 3. So it's crossing up here. It's a little bit steeper. It's 1 away from the axis of symmetry. So I'm going to move it 1 more the other direction and put another point there. That's the reflection point, or the point of reflection. I reflect it across the y, or the axis of symmetry. That's what it's for. I reflect this, reflect it over, and put it right there. That gives me 2 points to sketch my graph with. Be as careful as you can. You don't have a lot of points there, I know. Okay, we're doing the best of what we got. And that one's done. So this guy right here can save you a lot of time. Okay? It's the x-coordinate of your vertex. You still have to plug this one in, or plug it back in to find the y-coordinate, but it still saves you time. The axis of symmetry will be an equation, x equals negative b over 2a. So really when you find this, you find both of them. Piece of cake. And the y-intercept is going to be 0, c, whatever c is. C is this constant term, the term without a variable. Okay? Alright, so maximum and minimum values. They're just the vertex. The maximum value is the y-coordinate of the vertex. So if it's a minimum, it means it opens up and it's the lowest possible point. Lowest possible y value. If it's a maximum, it's the highest possible y value. That's the lowest because it gets lower and lower and lower. It stops. Then it turns around and y gets bigger again. The opposite here. Y is getting bigger. It's getting higher, higher, higher. It's getting bigger. Y is getting bigger. It stops, turns around, and y starts getting smaller. Okay? So if it asks for a minimum or a maximum, all you're doing is finding the vertex. So here's the question. Tell whether the function negative 3x squared minus 12x plus 10 has a minimum or a maximum. Well, that's really easy. Is that the highest point or the lowest point? It's pretty obvious the highest point, right? So that's the maximum. So we can circle this if you want to. Find the minimum or maximum. So I have to find my vertex, which is at negative b over 2a, and then I plug in y. This is going to be my maximum. So let's find negative b over 2a. Negative b. So in this case, b is already negative. So it's going to be a positive 12 divided by 2 times a. A is negative, so 2 times negative 3. The opposite of b over 2 times 3. Just because this is negative doesn't mean this number has to be. If this is negative also, then you're going to end up with a positive. So you have 12 divided by negative 6. 12 over 6 is 2. Positive over negative is a negative 2. So my vertex is at negative 2 something. So I'm going to get my calculator. I'm going to store a negative 2 for x this time. And then we've got, let's see here, negative 3x squared minus 12x plus 10. 22. So the maximum value is 22. Okay? As you guys are working on this homework, help each other out. Okay? If somebody understands it, help those who don't. Like I said, these notes are with the subfolder, so hopefully if you guys need to take a peek at them, they're available to you. Good luck. I know you guys will do fine. Okay, so your homework is a worksheet. I think I'm not sure what color it is. It might just be white. So good luck, and I'll see you when I get back.